Right, so question 2 of paper 1. F of x is equal to x squared plus bx plus c, where b and c are real numbers. F of x has a local minimum point at 3, comma, minus 1. Find the value of b and c. Okay, so when I see this, I'm going to differentiate the function. Okay, so f of x is x squared plus b of x plus c. When I differentiate that, I'm going to get 2x plus b. Right, so c is a constant, so it's gone. Now, I know that there is a point where x is 3. So when x is equal to 3, I can say 2 3's plus b is equal to 0. So 6, sorry, I'll draw that b properly just to make sure it's distinguishable from a 6. So that's 6 plus b is equal to 0. Therefore, b is equal to minus 6. Okay, so that's the first part. Second part then, so I've got another value, minus 1. So minus 1 is y, and y is the same thing as f of x here. So minus 1 equals x squared plus bx plus c, which now that I know what b is, it is equal to x squared plus, minus 6x plus c. Okay, and then I'm going to put in my 3 for x. So minus 1 is equal to 3 squared minus 6 3's plus c. Okay, so minus 1 is equal to 9 minus 18 plus c. So I've got minus 9 here. I've got minus 9 plus c. Okay, so I'm just going to move that over. So c minus 9 is equal to minus 1. C is equal to 8 when I bring it over here. Okay, so c is 8. So if you wanted to, you could write this now as x squared minus 6x plus 8. So that's equivalent to what this is now that you know what these two values are. Right, so for the second part, B, find the value of the following limit where n is a natural number. Okay, so the limit of the sum of these three pieces. Right, so the limit of the sum is the sum of the limits. So you just break this up and have three separate limits. So let's do that. So the first one is going to be limit as n goes to infinity of n all over n plus 1 plus the limit as n goes to infinity of n plus 1000 all over n plus the limit as n goes to infinity of 1 over 3 to the power of n. Okay, so how do you do these? Well, basically you get the largest denominator of the variable here, which in this case is n, and you divide both sides of it by it. So you end up getting the limit as n goes to infinity. So n divides into n 1 times all over n divides into n 1 times plus 1 over n, like that, plus the limit as n goes to infinity of n divided by n is 1 plus 1000 divided by n all over n divided into n is 1. Okay, so that's what that one looks like. This last one then, so if you think about this, right, so what's happening here, if you keep multiplying by 3, right, so if there's loads of these here, the denominator is going to keep getting bigger and bigger and bigger. There's no end to it. Okay, so that eventually will converge to 0. So the number will be so big, it'll converge to 0. So the answer there, I could leave the limit there if I wish, but it's going to resolve to 0. Okay, so that's that. So now let's take each one in turn. So 1 over 1 is fine. However, this one is also going to converge to 0. Plus, so 1 over 1 again. So n over as n divided into 1000 eventually will converge to 0 if n is big enough. Okay, so you've got, sorry, that's badly drawn there. So that's 1 plus 0 all over 1 plus 0. So you've got 1 plus 1 plus 0, giving you an answer of 2. So that's it for part B. All right, so part C of this question 2. The function g of x is defined for this range where x is a real number. Its graph is shown in each of the 2 diagrams below. Okay, so we see the exact same thing in both of them. Draw the graph of g of x minus 2. G of x minus 2 on the coordinate diagram below on as large a domain as possible. Okay, so all that's happening here is the y value is coming down two spots, if you like. So 1, 2, so that's going to be there for the first point. And let's take this point here. So if that's 1, it's going to be here. So the next one is kind of halfway between 2 and 3. So if I bring it down, it's going to be here, roughly. And the next one then is 7/8 of the way between 2 and 3. So it's going to be there, basically, just shy of number 1. And the last one then is going to be there. So it's the same thing. Now you can draw this with a ruler, the first part, the straight edge part. Geez, I made a mess of that. There should be a straight line, and then you have the curve, which will be identical to the other one. Okay, so that should end there. So you're just dropping it down 2 in each case for that one. So that's pretty straightforward. This one is slightly different now. So you can see here that it's the x value that's moving, and it's g of x plus 3. So for the x-axis, you'll remember this. This was always weird when people learned it. I remember it myself. So x plus 3 actually means it's going that way. It's not going that way, it's going backwards. So if I want to move this x plus 3, I'm actually shifting it over here. I'm going back this way. Okay, so that's the first one. So this one is going to be underneath as here. So the y points aren't changing here, the x points are. What's the next one here? 0. So 0 is going to be there. The next one is going to be here. And the next one is going to be here. Okay, so again, get your ruler to draw the straight piece and then draw the curve. All right, so take your time with it. It's difficult to draw it accurately on the computer here, but take your time with that and draw it as well as you can. And I think that's it for question C and for question 2. Okay.